Good morning. Of course, it's a great pleasure for me to come here. I'm very happy to be in a beautiful environment, and I thank very much the university and Carolina and Andrea for having organized this great event. So I'm going to speak about the software NooJ. NooJ is a linguistic platform that is used to describe languages. As of now, we have over 30 languages that are described with this tool. And NooJ is getting a little old. So it's like the linguistic engine that we have now in NooJ is over 15 years, maybe 17 years. So I think it's time to create a new engine, more modern, that allows linguists to describe natural languages in a more natural way, in an easier way, right? So that's what I'm going to present today. Okay, so I'm going to present now the new linguistic engine for NooJ. It's called Ra, you know, like the Egyptian god. It means recursive automata. Okay, so it's a new linguistic engine. So as of now, it's already published, so you can download it, you can play with it. Version is 0.9, so it's not the first version, right? There will probably, I hope there will be like some feedback, you know, some modifications. So it's open source, so you can look at the source. You can download it, you can do whatever you want with it. It's developed with a language, a modern language, which is called Swift. I don't know if you've ever heard about it. It's much better than Java or C# because it doesn't work on a virtual machine. I don't know if you ever heard about virtual machines, but they are not very efficient. Okay, so no virtual machine with Swift. It's compiled for each processor, so it's compatible with Mac if you have a Mac. Linux, Unix, and Windows, and as opposed to the current version of NooJ, all these versions will be identical, right? You don't have a Java NooJ and a Windows NooJ. It's the same NooJ for everybody. As of now, there are 19 modules, which means 19 functionalities, 19 linguistic type of phenomena that can be described, lexical, morphology, inflection, derivation, agglutination, syntax, local syntax, structural syntax, transformational syntax. And it's heavily tested as opposed to NooJ. You probably have heard about bugs in NooJ. Basically, for each function, for each little method in Ra, there are, in average, 2 or 3 methods to test the method. Okay, so it's tested, 9,000 lines of test code, and it's of course managed by a version control system, which means that if I find a bug, for example, and I correct it, I have a very minimal risk of introducing a new bug because of these tests. So every time I change something, these 9,000 lines of codes run to make sure that my correction does not introduce new bug. And if you have worked with NooJ, sometimes something worked, and then I release a new version, and then it's broken. So it was a little bad. So I don't know if you can see it, but if you want to download the source, if you want to look at these tests, looking at the test is an excellent way to understand the system, how it works. Because in each test, you see, there is a method that says, for example, lookup dictionary, right? And then there are maybe half a dozen tests to make sure that this method can look up a dictionary for a simple word, such as table, for a multi-word unit, such as a matter of fact, for prefixes, etc., right? So you can really see what each method, what each linguistic method can do. I don't know if you can go a little up. Up. Yes. Okay. This is a link. You will have access to to it. And if you click here, you're going to go to the next page. And so this is GitLab, which is an international repository of open source. So you go to this GitLab website, and as you can see here, these are all the source. Okay, this is all the linguistic engine, and of course RA tests are all the tests that you can check, right? And linguistic resources, as of now, for the test, for the testing, to test the engine, it's only English resources. But I hope that my friends in Argentina, in Spain, in Tunisia, will add or will help me add linguistic resources for their own languages, so that we are sure that the linguistic engine works and is very natural, it's natural from a linguistic point of view to describe each phenomenon. So we can go next page. Okay, so I need to speak a little bit about computer stuff, programming. So if you know NooJ, you already know what a .dic file is. It's a dictionary. It's basically the same in the new engine as before. IDX is an index. So for example, when you look up a concept or a word in a corpus, you want to have the results. It's in an index file. LST, it's a list of forms, for example, that you generate. If you know about the transformational engine of NooJ, like when you type, Joe loves Leah, and it produces 1 million paraphrases for it, transformations, such as Joe fell in love with Leah, Joe is Leva's lover, Leah is loved by Joe, etc., etc. Over 1 million variants, right? This is going to be pushed into a list. So you all know NOF. NOF files is inflectional and derivational grammars. So it shows the computer how to conjugate a verb, for example, or how to nominalize a verb. Demonstrate becomes demonstration or demonstrator. NOG is syntactic grammars, just like in NooJ. NOM, orthographic or morphological grammars, for example, to describe agglutination. And NOT is annotated text. And RA is what the new engine is based on, which is basically a multiple generalized finite set automaton. It's a specific machine, if you want. It's like a device, a computer device that can handle, that can manage every single linguistic resource, whatever the language. So it can represent dictionaries, morphological grammars, syntactic grammars, semantic grammars, anything will be compiled into a raw file. Okay? Next. Okay, so the little thorn, it's going to hurt some people, right? RA is going to be 95% compatible with NooJ. It means that there are going to be like 5% differences, 5% maybe problems. Of course, I don't want to just make a new engine that is going to be identical to the previous ones, right? The previous one had some defaults, was not very good at something, so I had to change things, okay? So the first thing is, as opposed to NooJ, every single machine, every single device is the same. It's a raw machine, right? The .RA, it's a multiple generalized finite set automaton, which means that we don't have anymore, .node, there were like 4 or 5 types of linguistic resources in NooJ, only one in RA. So dictionaries, orthographic, morphological, syntactic grammars are all converted into the same device. And they are all stored in the same file format. So there is no more difference between a dictionary and a grammar in the system, which makes maybe a little sense because in the brain, you don't have different types of neurons, so everything is represented the same way. In the same way, a bigger difference maybe for people who are working with dictionaries, as opposed to NooJ, where there were 3 types of dictionaries, de las, de laf, and de lae. So the last type dictionary, there was only one word, such as eat, and then the description, you know, like it's a verb, transitive, how it conjugates, etc. But then there were like the LAF dictionaries, in which the entry was not a word like eat, it was a form, like eating, right? And there was a third type of dictionary, de la E, for variants and frozen expressions. So too many types of dictionaries, in which only one type, you just have one entry and the associated information. So for example, instead of having this, eating, comma, eat, comma, blah, you just have just eating. And eating, and how do you go from eating to eat? There is a special property that says basically here, oops, that's a mistake, remove the suffix, okay? So, and this makes also the system much more robust in terms of neutrality. What I mean by neutrality is that now the dictionary is totally symmetric. You can use the dictionary to analyze the text. So for example, if the dictionary finds eating in a text, it will be able to automatically find eat, right? Compute eat from eating, but also, thanks to this system, compute eating from eat. So it's now the RA, the new device are totally symmetrical. You can use them to produce words, to produce text, or to analyze text. It's much better. There is a new operator in grammars that it's a collocation grammar. There are people who are using NooJ, you know, to parse. They are not linguists, but they want to process text, for example, to find if a certain political personality who is maybe like supposed to be to the left. Actually, when he speaks, you know, he has some. He uses some terms that are usually used by right people, right? So political studies, sociological studies, they are interested in collocations. And if you ever heard about fake news, for example, it's very hard to make a grammar of fake news because people who are writing fake news, they are very careful. They are not going to say, this is a fake news, right? So what they do is they use some terms, you know. Each of these terms looks like it is okay, but when you have a collocation, when you have this plus this plus this, now you understand that something wrong is coming. So for example, let's say you have a text in which there is a word pizzeria, right? Pizzeria is just neutral, right? There is nothing wrong about speaking about pizzeria. But then, if you have in the same text, in the same context, Clinton, you see, that could be a flag. I don't know if you have heard about the fake news about Pizzagate. You know, like, in Washington, D.C., Clinton was supposed to have a pedophilia ring in a certain pizzeria, okay? So pizzeria by itself is totally neutral, Clinton too, but if you have in the same paragraph these two words, there should be some flag coming, and you can write a grammar like that. So this new operator means something like these two words, these two concepts have to be somewhere in the vicinity. Okay? This would be very difficult to write with a NooJ grammar, right? Because we don't know what's between these two words. So you would have to put the punctuation, any word, and then there is the order problem also. You could have Clinton before pizzeria, etc., right? So this is a new operator. And there are some specific little technical details about some specific symbols, such as this one, which was a really bad choice for NooJ, because this meant sometimes comment, you know, when you want to comment a dictionary entry or in a grammar, and sometimes it meant concatenation operator, you know, when you want to have a prefix followed by a suffix. It was very bad, so we changed all this. So this is replaced with this with this. I mean, these are little technical things. Okay, next. Okay, there are some very big differences I want to explain to you. So there is a funny word in English, I mean in English, right? which is supposed to be, I can't even pronounce this, pneumo ultra microscopics silico volcano coniosis. It's supposed to be the longest word in English, right? How do you proceed? How do you describe agglutination in NooJ? As of now, you have to write a grammar like that. So this says something like any letter followed by any sequence of letter, right? And then you put this in parentheses and you say, maybe this is a prefix, right? And if it's a prefix, you go all the way in order to go all the way to the noun, right? This is a terrible idea. First of all, I hope everybody sees that this is it's not clear, right? Do you understand what it means? I mean, it's complicated, right, to understand this grammar. But also, from a computer point of view, it forces NooJ to split, you see, the word, to see, let's say, is PN a prefix? Is PNE a prefix? You see, it has to test all the possible cat in this word and test if all this cat corresponds to a sequence of prefixes. So how many tests does it have to do? Basically, 2 to the power of n. 2 to the power of n, because any cat could be anywhere between all these letters, right? 2 to the power of n, it means that I can't even tell you how much this is. That's 35 billion 184 billion. I mean, this is crazy, right? So just analyzing this would force NooJ to split, to make all the possible splits and test afterwards if there are prefixes or not. That's impossible to do. And we have already tried to parse Germanic languages. You know, in German, you could have also long words. It's not as bad as this, right? But it's pretty bad. And already you can see that NooJ has difficulty parsing German compound words. So the new system is much faster. You go. Okay. If you want to write the same grammar in the new RA engine, it's super easy. You just write prefix. Star means any sequence of prefixes followed by a noun. That's all. But the advantage of this system, well, first I hope that you see from a linguistic point of view, from a linguist point of view, this is much easier to understand than this, right? But also, when NooJ sees this symbol, it just looks up the dictionary, and if there is no prefix, it stops. And when it sees a prefix, it just continues to look at the prefix. So instead of having the time being proportional to 2 to the power of the length of the word, it's just linear. So the time it takes to read the word, it has analyzed it. So it's much more natural from a linguistic point of view, and it's much more efficient from a computer point of view. So I'm going to, okay, so all these functionalities, you know, like in NooJ, you have NooJ apply, but NooJ apply is pretty limited. You don't have access to every single functionality. In a RA, you can download it, you can look at it, and you have access to, as of now, I think 10 or 11 functionalities, all of these. There are little programs that you can just use yourself, right? So I'm going to, okay, so go. So I'm going to just give you a list of these functionalities very quickly. So let's do this one. Okay, so there is a problem with the PowerPoint, but basically dig2lst, as its name tells you, it takes a dictionary and produces all the forms that correspond to the dictionary. So LST, remember, it's all the generated forms. So you have a dictionary in the RA format, which is close to the NooJ format. You just type in dig2lst and your dictionary, and it produces, it automatically conjugates all the words of your dictionary, okay? And it gives you the list. So it's easy for you if you construct a dictionary to see if the verb, for example, was properly conjugated, right? Next. When you have a list, now there is another command which tells you, when I have the list, I want to transform it, right, to compile it into the device I was mentioning, the RA device, right? Every single linguistic resources, dictionaries, grammars, syntactic or morphological, are going to be transformed into a device, a computational device, that will be able to analyze or generate what you want, okay? So if you have the list that you produced before, you can LST2RA means I take the list and I transform it into an automaton, RA, recursive automaton. So it says here, you see, LST, I take the list that I just generated before, and it produces the corresponding device. Okay, you can combine, of course, these. If you know a little bit about how to use a computer, you know, in this mode. Here, I took the dictionary, test.dic, and then I produce all the list of the forms, but instead of putting them in a file, I pipe them, you see, I give them to the next command, and then I get directly the recursive automaton. Okay, recursive automatons, you want to see how they look like, right? So they are machines with states, you know, like an automaton, you know, an automaton could be like sit, standing, turn, you see, like this automaton like in the 18th century, right? They have states, and then from one state they can go to another state. So if you want to look at the states, at the recursive automaton, how does it look like inside the memory? There is a command, print ra, basically, that tells you exactly how it's what it looks like internally, right? So here you have the states. State 0, it starts at state 0. Let's say, you know, the automaton is sit down, and then if there is a state up, it goes up and it turns, etc. So these are all the states. So for example, this is a dictionary that I just created. So I start here, and if I find A, I go to state number 2. It's super easy to understand. And now I go to state 2. If I find a B, I go to state 3, etc., right? And then when I arrive in state 1, which is a terminal state, I found my word, and I have analyzed it, okay? This is now nom to ra. It takes an orthographic or morphological grammar, and it produces the same ra device. So I'm not sure it's clear if you're in the back, but here it's a little grammar that says A or B star, A, B followed by A or B star, which means I want to recognize all the words that contain an A and a B next to each other. And then nom to ra, I take this grammar and it compiles the corresponding automaton. So this is an orthographic grammar that has been converted into recursive automaton. Of course, you have several types of recursive automatons. You have deterministic, minimal automata, and you can, where is it? You see here. Okay, the previous one, I think you saw it, it's big, right? It was a big, you had a little grammar, but then the generated automaton was pretty big. But you can here determinize or even minimize the automaton, and the corresponding automaton is very, very small here, you see? Here it says, I am at state 0. If I find an A, I go to state 2. If I can find an A, I stay in state 2. And if I find a B, I go to state 1, and state 1 is terminal. So you see, to recognize all the words that contain a certain affix inside, it could be done very, very efficiently here. But this automaton has the same behavior as this one and as the previous one, which was pretty big. So if these are optimization, you control them. Yeah. So this is exactly the same with syntactic grammars. Now, instead of letters, now you can have words. So for example, this grammar says the or this, followed by an adverb, an optional adverb, followed by an adjective, and then followed by a singular noun, right? It's probably not big enough. You will have access to the PowerPoint after. Well, same thing. I have a state, initial state. If I find the, I go to state 3. If I find an adverb, I go to state 4. If I find an adjective, I go back to state 1. And then in state 1, I go to, if I find a noun, singular noun, I go to state 2, and then I'm done. So this little device recognizes, little noun phrases. The, adjective, and noun. Okay, so as opposed to NooJ, now you have the possibility of entering a grammar to recognize sentences. Where the sentence stops. Okay. Usually in NooJ you were applying grammars paragraph per paragraph. Now you can apply the grammars sentence by sentence. So you need a grammar, right? So this is an example, a little text, right, in English from the Portrait of a Lady. You have two possibilities. This segment command takes the text and segments it into text units, okay? If you don't give it any parameter, just segment and then your text, it will just split paragraph per paragraph. So you see here there is chapter 1 and then there is a paragraph, and when you use the command it gives you two text units. First text unit is a chapter 1 and the second text unit is this paragraph. Next. But you can use the same segment program with a NooJ grammar, or RA grammar, right? So this is a little grammar that explains to the system how to split a text into sentences. So it's a simplified grammar. I just want to show you. So how does it work? The main rule is here. If I find a beginning of paragraph, followed by a delimiter, followed by, a beginning of paragraph, there are three types of sentences, sorry. So beginning of paragraph is here. So this is a beginning of paragraph, followed by spaces, followed by a word in uppercase. So you see, if you have a paragraph that starts with a word in uppercase, it's probably a good way, a good idea to split here, right? And then delimited. Delimited is here. If I find a delimiter, so what is a delimiter here? It could be a period, exclamation point, or question mark. So if I find a delimiter or a series of delimiter followed by a word in uppercase, same thing. It's a good idea to split there. But there are some exceptions with proper names. For example, so the proper name is here. If I have Dr., you see Dr. John, the problem is you have a period, you see this here, followed by a word in capital letter. But you don't want to split here, right? So this rule says, you see, if I find doctor or professor or Mr., Mrs., or Ms., followed by a word in a capital, you see here, I do not split. Okay, so you could enhance this grammar, but basically it's a simple grammar, right? Orthographic grammar, and now I transform this grammar into a RA, right? Nom to RA, and then I segment the text with this new device, and instead of having two text units like before, now I have 8 text units. It splits the text properly into sentences. Okay? Okay. Print task. So you know that in NooJ, how does NooJ analyze the text? Basically, it annotates the text. So what it means is that you have your text, and then from here to there, I found a noun. From here to there, I found a verb. Or from here to there, I found a noun phrase, or a question, or a declarative sentence in the past, right? So you can add annotations anywhere you want in the text. Well, you want to look at the task, right? So task text annotation structure. So here what I did was I just printed the task. So the text annotation structure. Of course, I just segmented my text, so there is nothing in the task. There is no annotation, but you can still see. You see, it tells you where it split the text. You see, position from 11th character to the 145th character. There is a sentence, and then it gives you the annotation. There is no annotation now. Okay, we are going to apply linguistic resources to get these annotations. Okay, so now lexical analysis. So lexical analysis exactly corresponds to, you know, in NooJ you had info preferences lexical analysis, where you would apply dictionaries and morphological grammars, right? And now orthographical grammars as well. So how does it work? I just wrote a stupid little sentence. The XR, ZZZ, doesn't redismount drinkable ultra microscopic tears, right? This is just silly to show you that there is a grammar, orthographical grammar, that finds CZAR and recognizes that it's a variant, spelling variant of TSAR. Okay? There is another grammar that says if I have a word in uppercase, like Z, uppercase Z followed by something, and I have not found this word in a dictionary, it could be a proper name. Doesn't, so there is a grammar that says, oh, if I find doesn't, I want to process it as does not. It's two words, verb, adverb. Redismount, same thing. I cut the split, I split the prefix. So if I find redismount, I will analyze it as mount with prefix re and prefix dis, redismount. Drinkable, same thing. There is a morphological grammar that takes drinkable and splits the able and says, oh, this could be an adjective derived from the verb to drink. And ultra microscopic, this is the grammar I showed you before. So I apply it, lexical analysis, to the text that I already segmented before. And then I add the grammar contractions, tsar, re followed by a verb, verb followed by able, and then the list of prefixes, proper names. And then now you see if I print the task, the text annotation structure, you see here, tsar here has been annotated as TSAR. So you see it normalized the spelling. Doesn't here has been analyzed, and look at that, do, a third person present, singular, followed by not, adverb, right? So these are the positions in the text. You know, like when you annotate a text, you have to know from where it starts to where it goes, and then you say, well, this is a verb, this is a noun phrase. The problem is, the interesting thing is, sometimes, for example, in French, du is a contraction of two words. So it looks like it's one word, but in fact it's a preposition de contracted with the determiner le. You see? You have this in Spanish also? Contractions, right? Yes. Okay, so how do you represent the annotation? Well, this is how it does here, you see. The annotation starts at character number 14, right? But then it goes to, you see, 14.01, right? So it's like a half a character if you want, right? And then from 14 from 14 to 14.1, you have do. And then from 14.1 to 21, which is the end, the next word, it finds not, the adverb. So actually, how many prefixes you can have in this new system? You can have 255 pieces in a word. So it's more than enough for any known language, even Turkish or Finnish. We are good, okay? So you can split any word. And when you have ambiguities, such as here, it recognizes that redismount is an occurrence of mount, right? But the problem is there are three meanings for mount. So 3 lexical entries. It's not even meaning, it's the person is different here. So you have annotations at the same place. Okay? How much time do I have? It's finished? Okay. Just go back 1 second. Sorry. Just one second. You see here, it's not very very nice, because if you want to perform lexical analysis, you're going to have dozens of lexical resources, right? You have dictionary of spelling variants, you have dictionaries of proper names, of technical terms, and also contractions, prefixes, etc. So instead of having to put every single argument, every single linguistic resource in the command, you can do the following. So now you can write all your preferences, all your linguistic resources, you put them in a text, in a file. I don't know if some people know about JSON, you see? Okay, it's a way to represent all these linguistic resources, and in this file, you put all the lists. So you see tsar, contractions, dictionary, reverb, verb able, etc. And you give them priorities. Priority 1, 2, 3. Remember I said ZZZ, you only want to test it, to analyze it as a proper name if this word is not in a dictionary. Because of course you don't want to process every single word in capital letter as a proper name, right? So only if it's not found somewhere else, so you would give it a low priority, okay? So you can use the same command, lexical analysis, but this time, instead of having to give all the linguistic resources, you just give the file in which they are all described. Well, we have the same system with syntactic analysis. So this is the same text here. So I segmented it into 7 sentences. And then I applied the lexical analysis, just like before. And now I'm writing a syntactic grammar. So this syntactic grammar says something like, I want to recognize noun phrases. So I have 2 types of noun phrases, singular and plural. So let's say, for example, singular, you would have a singular determiner, and, some, the, this, part of the, such a, the flood of, followed by an optional adjective, adjective or nothing, followed by a noun in the singular. Just very simple syntactic grammar, right? So you use syntactic analysis, you apply here syntactic analysis to the text with this grammar, and it gives you 32 annotations. It found 32 noun phrases in this text, so you can print the task. So you see the task, it says, well, it found a noun phrase from character 192 to character 199, okay? So again, it's not very visible, but it's an index, right? So, next. Okay, so what was it? So this was, oh yes, this is before. Oh, when you apply, you perform syntactic analysis, you can do 2 things. You can add annotations. For example, from here to there, I found a noun phrase. But you can also remove ambiguities. So for example, in Spanish, the word la could be a determiner or a pronoun, right? So if you perform only the lexical analysis, it will give you 2 annotations for la, determiner or pronoun, because it looked up the dictionary and there are 2 possible analyses. But with syntax, now you look at the context. So you can say, oh, here I know that la has to be a determiner, for example, because it's followed by a mesa, la mesa, right? So you know it's not the pronoun. So you can write a very simple grammar that will remove ambiguities, and this is what I think I did there. So here I have the same text, the Tsar doesn't respond, blah, blah, blah. So lexical analysis gives me these annotations, these tasks, and then I have a disambiguation grammar that says, here, if I find do followed by an adverb, followed by a verb, right? The verb has to be in the infinitive. So remember that I showed you that mount before. There were 3 annotations from mount. Oh, sorry, we can see them here. Because it could be either first, second, or third person plural. We mount a toy. It could be also first or second person singular. I mount, you mount. And it could be also the infinitive. So 3 potential analyses for mount, right? So this grammar says if I find do followed by an adverb followed by a verb, the verb has to be in the infinitive. You cannot have I do not and then a verb in the first person singular, right? So this grammar, I apply it, and if you can scroll a little bit, you see, stop. You see, that's before. I have 3 annotations for mount, and this is after. The remaining annotations is only 1. It's mount, infinitive. Okay? So these syntactic grammars can be used both to add annotations or to remove annotations. Okay? Okay, that's what I wanted to show. Okay, so remember, most of the time people who are using NooJ, they do text locate, right? So you look for something in a text. So this is how it's done here. It's called syntactic locate, okay, in RA. So you have the options, shortest match, longest match, or all the matches. And then you have your text. You can have more than one text. You can perform one analysis, one locate system. You can apply one query to, 1,000 text in one run. And then you have your query, which, no surprise, it's also a raw machine. And then it applies the query. So where is my query? Oh, this is it. Here. Do you remember that I added the annotation NP, noun phrase, before to the text? Right, with the syntactic analysis. So now I can reuse it. So here I say, I want a preposition followed by a noun phrase. You say, I can do that, right? And then I can produce an analysis such as Zozo, hello. Here I said prep phrase, okay? So this prep was an annotation that was added by the dictionary lookup. When you look up the dictionary, you have, let's say, of is a preposition, right? Whereas the NP here, this annotation was produced by the syntactic grammar that I showed you before. The or this followed by a potential adjective followed by a noun, right? But now they are all together in the task, in the text annotation structure, so there is no problem to apply a query that mixes them, right? Preposition followed by a noun phrase. So I apply it to the text, the same text, and then it found, I don't know how many, 2, 4, a dozen preposition followed by a noun phrase. So it's an index, remember? An index. Okay, now? So this is, these are the locations. And concordance, that you know all about, it takes the index and it tells you what it is exactly in the text. So here, it takes the index I just built, and I ask 20 characters before, 20 characters after, and you see, it produces the result under certain circumstances, then the hour, to the ceremony, upon the lawn of a splendid summer, you see, in context. So you have basically the basic functionalities of NooJ, you can perform them. So I understand, you understand that this is just an engine, which means that you will not probably want to use them, but it means that you have access to these functionalities, if you want. Now, of course, the next step is going to be building, let's say, an interface, a graphical interface, so you don't have to type in this command. You can click just like in NooJ, right? But this is totally separated from the engine. As before, it was very difficult. It was not separated. You had NooJ, and you couldn't just use just one functionality. You had to click somewhere. Okay? So perspective, so what am I going to do now? Well, this is version 0.9, so I hope some of you, maybe, or your students or colleagues, will play maybe with it and tell me maybe I have to do some modifications. I'm getting ready for version 1.0. As of now, if you download it, the programs, they work on a Mac. So I have to recompile them for Windows, Linux, and Unix. That shouldn't be a problem. There are Swift compilers for these systems. I will do it probably this summer. If you ever, I don't know if some of you have worked on discontinuous expression, frozen expressions. I know that for English we have Peter Machonis worked on phrasal verbs, you know, turn the light off, how to recognize them. As of now, it's not very natural. It's a little difficult to explain to the system, to describe frozen expressions and discontinuous expression with NooJ. So I am thinking of doing something much easier to understand, a little bit like morphology, remember? Instead of having stars with airs to recognize prefixes, you just write prefix followed by a noun, and it does the job. So I'm going to do something about it. The transformational engine is not finished. You know, the transformational engine takes one sentence and then, for example, put it in the passive. Yeah, so you need special grammars to do that. And then, of course, all the tests that I've done are for the English language. So now we have 30 languages in NooJ. So I want to make sure that all this linguistic engine works for these 30 languages. So we will have to work with each of you, maybe for Spanish, with someone from here. And also add a graphical interface. What I'm thinking of is instead of building one graphical interface for Mac, another one for Windows, another one for Linux, and another one for Unix, because all these systems are vastly incompatible, maybe one idea would be to write a web interface, you know, so that you could use NooJ on any machine and with your favorite browser, Chrome or Safari or whatever, and it would look exactly the same. And this would also allow me to put NooJ maybe on a server. So you would not even have to download NooJ. You would just go to a website and then you would have, you know, that's what I'm thinking of. And I don't know if you have heard about ATISHS. There is a page on it. So this system, ATISH, has something like a dozen statistical tools. So, for example, you could ask for some collocation, like is this very frequent or not frequent enough? I mean, there is a dozen statistical tools that are available that run after NooJ. So when you found, let's say, a noun phrase or fake news, for example, you could perform some statistical measurements on fake news in this newspaper versus this newspaper. So these could be easily added to the linguistic engine because ATISH was also constructed, developed with the same language. So it would be easy to add them if I have interest, if some of you are interested to perform some statistical analysis. Let me know. Thank you. I think it's not completely done. Ah, yeah. Okay, so it's open source, it's collaborative. Anybody can go on this website and add their things. You know, you can change the code. You can add your linguistic resources. It's open source and public. So please collaborate.
Okay. Well, firstly, thank you because we need a version compatible with different systems. Yes. I have two questions. The first one is I can. What? Okay. The first one is so I can build my resources in Mac and share with Linux, Windows, etc.
Yes.
Okay. The second one, for me, the main attraction for the actual version of NooJ is that it's friendly for users that have few computational knowledge. What happened with this version, with RA version?
RA is not supposed to replace NooJ. This is a linguistic engine. So we have to build now the graphical interface. Okay. But the linguistic engine, it's important because it's how you describe a language. So this is a linguistic part, if you prefer, right? So I could use an interface that looks maybe exactly like the one in NooJ, maybe, right? Okay. Or if you tell me no, you don't like this interface, what about some modifications? I will be happy to change it. Okay. Perfect. But the fact that the linguistic engine is now compatible with Linux, Unix, Windows, and Mac, right, allows me to have only one interface, one file format for everything. So it will be feasible, right? Oh. If I build an interface, a graphical interface in web, you know, in the HTML or JavaScript, right, it will work on any platform exactly the same, right? But also the fact that now you have access to the linguistic engine means that you could decide, you could make your own interface if you wish. You could write, let's say, very easily, maybe in half a week, you could write a mini NooJ, right? Because you just need the query, you know, text locate. You don't need to build new dictionaries. You already have your dictionaries. You don't want to build grammars. You just want to have a little query on your corpus. It would take maybe 2 days if you know how to build a graphical interface. You just draw a window, just a button, and then you apply, you look at syntactic locate. And when you push the button, it calls syntactic locate. So anybody now can build their own NooJ with this system.
Okay. Thank
you. This is the engine.
Max, thank you for your presentation. Very clear, please. My question is, can we adapt our dictionaries and our resources in Spanish module, maybe, in the new formulation of NooJ?
Yes.
In RA?
Oh, of course, we have to do that. I mean, it should work pretty easily, but maybe it's 1 day of work to make sure that if you have used some special functionalities, for example, the variants, you know, so now they are not described exactly the same way, but I think in 2 hours, maybe you and me, we can sit down and we can modify it so that it works with the new engine. Yes.